Hi, hello, how are you all? So, this is your Gopal. Today we are going to discuss gravitation lecture number 2. Gravitation lecture number 2. In lecture number 1, we can discuss what is the gravitational force and its characteristics. Gravitational force F is equal to capital G m1 m2 by r square. m1 m2 by r square. Here G stands for what? Universal gravitational constant. That value is 6.67 into 10 to the power of minus 11 Newton meter square kg minus 2. And its characteristics you can discuss. Today we are going to discuss. So what is relation between capital G and small g? Discuss acceleration due to gravity. Here acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity denoted by a symbol is what? Small g. What is acceleration due to gravity? Acceleration of a body due to gravitational force is called what? Acceleration due to gravity. Acceleration of a body due to gravitational force is called what? Acceleration due to gravity. That symbol is what? G. So here today we are going to discuss relation between capital G and small g. What are the relation between capital G and small g? Gravitational constant and acceleration due to gravity. Suppose consider a body. So you can consider Earth. Earth mass is capital M, and its radius is capital R. Suppose body is placed on the surface of the Earth. That is what mass, small m. I will consider small m. So what is gravitational force in between this capital mass of the Earth and small body of the mass is m. What is the gravitational force? F is equal to capital G, capital M, small m by r square. So here body weight is acting downward. So here F is equal to weight. So mg is equal to capital G, capital M, small m by r square. So you can cancel the small m and the small m. So here G is equal to capital G, capital M by r square. So this is acceleration due to gravity G and universal gravitational constant capital G relation. Small g is equal to capital G, capital M by r square. Okay. So here what is r? Radius of the Earth. What is m? Mass of the Earth. What is g? Acceleration due to gravity. What is capital G? Universal gravitational constant. So here acceleration due to gravity depend upon mass of the Earth and radius of the Earth. Acceleration due to gravity does not depend upon mass of the body. And shape and size of the body. Acceleration due to gravity depend upon mass of the Earth and radius of the Earth. So does not depend upon mass of the body, shape and size of the body. So same acceleration in terms of density, in terms of mean density. Same acceleration due to gravity, small g, in terms of density, mean density rho. So in terms of density means you can write small g is equal to, we know mass is equal to volume into density. Mass is equal to what? Volume into density. What is volume here? That is a sphere. Sphere volume is equal to 4 by 3 pi r cube. 4 by 3 pi r cube into density. So here what is the volume? 4 by 3 pi r cube rho. 4 by 3 pi r cube rho. So substitute here. What is acceleration due to gravity? We know capital G, capital M by r square. So here capital G, capital M is 4 by 3 pi r cube, 4 by 3 pi r cube rho by r square. So here one r square cancel means only remaining is r. So G is equal to capital G 4 by 3 pi r rho. So this is acceleration due to gravity in terms of density. Acceleration due to gravity in terms of density. Right. So next we can discuss variation of acceleration due to gravity. Variation of acceleration due to gravity in terms of height, in terms of depth, in terms of poles, in terms of equator, we can discuss. So next variation of acceleration due to gravity. Variation of acceleration due to gravity. Variation of small g. Variation of small g. So first one, variation of g in terms of altitude. Variation of g in terms of altitude means in terms of height h. So we know acceleration due to gravity. So g is equal to gm by r square. Gm by r square. So when body is on the surface of the earth, when a body is on the surface of the earth, formula is what? G is equal to capital G capital M by r square. In case this is the mass of the earth, so this is radius is r. In case body is raised some height h, so that height must be less than or equal to radius of the earth. So here we can write in terms of height h. So we can write gh is equal to capital G capital M by r plus h whole square. So this is the mass of the body. Now what is the distance between these two? This center to this mass, r plus h whole square. So now you can do equation. So here common r square value. So gh is equal to g capital M by r square, you can common r1 plus h by r whole to the power of 2. So gm by r square means you can write small g. So here you can write gh is equal to g by 1 plus h by r whole square. So this term bring up, you can write this one. So gh is equal to g of 1 plus h by r whole to the power of minus 2. Due to binomial expansion, we can write this one. So gh is equal to g of 1 plus 1 minus 2h by r due to binomial expansion. Due to binomial expansion, binomial expansion. Due to binomial expansion, you can write. So gh is equal to g of 1 minus 2h by r. So this is acceleration due to gravity in terms of h. Gh is equal to g of 1 minus 2h by r. Next, so here height must be less than or equal to less than of the radius of the earth. Far less than the radius of the earth. So same acceleration due to gravity in terms of altitude. For a smaller altitude, we can write this formula. Okay. At a smaller altitude, so we can write this formula. gh is equal to g of 1 minus 2h by r. So we can write this g, bring this side. So gh by g is equal to 1 minus 2h by r. So we can write this one. This 2h by r bring this side, and this gh by g bring this side. So we can write this equation. 1 minus gh by g is equal to 2h by r. So here you can do the LCM. So g minus gh by g is equal to 2h by r. You can write g minus gh by g is equal to delta g by g is equal to 2h by r. So for a smaller altitude, delta g by g is equal to 2h by r. You can write this one. So delta weight delta w by w means not w, weight. So delta change in velocity, change in weight by weight is equal to, you can write this one is 2h by r. In terms of weight, you can write delta w by w is equal to 2h by r in terms of weight. So next you can discuss in terms of depth. So here you can get in terms of altitude, height. So gh is equal to g of 1 minus 2h by r. So here condition is height is far less than the radius of the earth. and due to binomial expansion you can write this one. So here for a smaller altitude we will get delta g by g is equal to 2h by r, or in terms of weight you can write 2h by r, dw by delta w by w is equal to 2h by r. Next, second one, be in terms of depth. In terms of depth. So we know, so suppose this is a mass of the body is m. So now in d depth, so body is placed here. This is the d depth. So this is the radius. This is radius of the earth. The radius of the earth. So we can write in terms of density formula already we know. So G is equal to in terms of density, G is equal to G 4 by 3 pi r rho. 4 by 3 pi r rho. So what is here? So what about this distance? This total mass m, and this is from this mass to this mass, this is a small m. So this distance is what? R minus d. So you can write in terms of d, Gd is equal to capital G 4 by 3 pi rho r minus d. 4 by 3 pi rho r minus d. So here you can write, so divide both equation, you can divide. Gd is equal to G 4 by 3 pi rho, r is common means 1 minus d by r. So G 4 by 3 pi r rho means what? You can write small g. So here Gd is equal to G of 1 minus d by r. So this is acceleration due to gravity in terms of depth form. Variation of acceleration due to gravity with depth. B with variation of acceleration due to gravity with depth. So this is, you can consider this is the mass of the earth is m. This is what? Radius is r. So at d depth mass is placed. So this is the mass small m. So what about this distance? R minus d. Suppose you can write acceleration due to gravity in terms of depth formula. So acceleration due to gravity in terms of density you can write. So G is equal to capital G 4 by 3 pi rho r. So in terms of depth also you can write Gd is equal to capital G 4 by 3 pi rho r minus d. So here r common, Gd is equal to G of 4 by 3 pi rho, r common 1 minus d by r. So G 4 by 3 pi rho r place you can write small g. So Gd is equal to small g 1 minus d by r. So this is acceleration due to gravity in terms of depth. Acceleration due to gravity in terms of depth formula is Gd is equal to G of 1 minus d by r. So acceleration due to gravity and radius. So you can find radius. In terms of x-axis you can consider r value, and in terms of y-axis you can consider g values. So we know in terms of depth formula, Gd is equal to capital G 4 by 3 pi rho r minus d. So can I consider here, this is 4 by 3, G 4 by 3 pi rho is constant. So r minus d place I will write small r. So I will consider r minus d is equal to r. So here can I write Gd is equal to, this total term is constant, Gd is proportional to r. So acceleration due to gravity at center of the earth is equal to 0. Why? Because, so you can consider, so before value Gd is equal to G of 1 minus d by r. In place of d you can write r. So here d is equal to r you can write. So Gd is equal to G 1 minus r by r. R by r is 1. So minus 1 plus 1 0. This term is total 0. So Gd is equal to 0. G depth is equal to 0. Where at center of the earth. At center of the earth acceleration due to gravity is equal to 0. The center of the earth acceleration due to gravity is equal to 0. Suppose you can consider here, this is the origin. This is the center of the earth. This is the center of the earth. So here GD is proportional to R means in case this radius is increases, this distance is increases, acceleration due to gravity also increase. This distance is decreases, acceleration due to gravity also decrease. So while going depth, acceleration due to gravity decreases, up at the center of the earth is equal to become 0. While going from center of the earth to surface, acceleration due to gravity increases. Acceleration due to gravity increases. So here from center of the earth to while going surface of the earth, acceleration due to gravity G is proportional to R. Acceleration due to gravity increases. At the surface of the earth, so this is at the surface of the earth, 9.8 meter per second. So origin to going surface, acceleration due to gravity increases. So we know in terms of height formula, so GH is equal to capital G, capital M by R plus H whole square. So here can we consider R plus H is equal to small r. So GH is equal to capital G, capital M by R square. This is a constant. So GH is proportional to 1 by R square. So while going height, acceleration due to gravity, you can plot the graph like a parabola. So this is G is inversely proportional to 1 by R square. So this point R is equal to radius of the earth. Small r is equal to here radius of the earth. So this is you can move above from the surface. So this part is inside the depth. This part is above from the surface. So while going height, G is proportional to 1 by R square. While going depth, G is proportional to R. So from origin to surface of the earth, acceleration due to gravity increases. And while going height, acceleration due to gravity decreases. See, variation of G with latitude. With the latitude. So we know latitude. So this is the earth surface. So this is latitude. This is what equator. At a particular point, you can find out the acceleration due to gravity. So this is the center of the earth. So you can draw this particular point. So this is a radius. This is makes an angle theta. Makes an angle theta. So we know one formula in terms of with the latitude. So G theta is equal to G minus R omega square cos square theta. Remember this formula. So G theta is equal to G minus R omega square cos square theta. So what about at equator? At equator. So this becomes equal to 0. This is comes to along the equator. So angle is theta is equal to 0. Theta is equal to 0. We can write this equation. So G theta is equal to G R omega square. So cos 0 value is 1. So this term is total 1. So R omega square. So G theta is equal to G minus R omega square. So at a pole, what about G theta? At a pole, this coming like along this. So angle is 90. So cos 90 value. So G theta is equal to here theta is equal to 90. Theta is equal to 90. G theta is equal to only G. Why? Because cos 90 value is 0. This total term is 0. So G theta is equal to G at the poles. With the latitude formula, G theta is equal to G minus R omega square cos square theta. G theta is equal to R omega square cos square theta. So at equator, theta is equal to 0. So G theta is equal to G minus R omega square. At the poles, theta is equal to 90. G theta is equal to G. So this is variation of G with respect to latitude. So next we can discuss variation of G with the shape of the earth. Shape of the earth. So earth is not a perfect sphere. So it is like not perfect sphere. At equator it is bulged. At the poles like a flat. So What is distance between the center to pole? Distance is little bit less. So here distance between the center of the earth to equator. So distance distance is more. So we know formula G is equal to capital G capital M by R square. In case distance is decreases, acceleration due to gravity increases. Inversely proportional to know. So at poles, acceleration due to gravity increases. Means at a pole, G value is maximum. Next, G is equal to capital G capital M by R square. At the equator, you can see at the equator radius is increases, acceleration due to gravity decreases. Means at the equator, so R value is increases, G value is decreases. At the equator, G is minimum. At equator, G is minimum. At the poles, G value is maximum. So what we discussed today? What is the relation between acceleration due to gravity, small g, and capital G? So capital G, small g, very different relation is. What we discussed today? Relation between capital G and small g. So small g is equal to Gm by R square, and variation of g with respect to height, depth, latitude, and in terms of same. Okay na? So variation of g while going height, acceleration due to gravity decreases. While going depth, acceleration due to gravity decreases. At the shape of the earth, at the poles is maximum, at the equator is minimum. So this is discussed today. So tomorrow we can come to the next topic. So all of you listen my videos carefully, and please like, subscribe, and share my videos. You regularly watch my videos. Please don't forget. Please, so all of you bye. Take care. Have a nice day.